Okay, Matrix, now you need to focus on this. Okay, we've looked at fx notation, grade 10s and 11s, and we've understood that the f of 1 is really the y value there. So if x is 1, y is 2, and that symbol, f1 is the y value. fx represents the y value. Okay, now Matrix, watch this. I'm going to show you the concept of a limit. This is very exciting. If we approach x's from the left and the right, as we approach 1, now, don't get too technical with this. Okay, you don't have to worry. Okay, if you're doing university maths, that goes quite technical, but don't worry. Just remember, as we approach 1, what are the y values doing? They're approaching 2. Now, 2 is the limit. As x goes to 1, the y values are going to 2. So, let's have a look at some notation. What we say is the limit. If x approaches 1 from both sides, you're coming to 1. What are the y values the fx is doing? Okay, well, let's have a look. fx is x squared plus 1, which is the graph of the parabola. And if you then drop the symbol limit and you plug in the 1, you get 1 squared plus 1 is 2, and that is your y value. It's the y value which you approach. Now, don't panic with this. It gets quite technical at university. But all you need to understand is the concept of the limit. As the x's are going somewhere, what are the y values on the graph doing? As you can see, if the x's approach 1, the y values are approaching 2. So if we have a look at an example, if the x's approach minus 4, what's the limit of this funny graph here, which is a parabola again? All you got to do is drop the limit as you sub in, and you put in negative 4 squared plus 4. And it simply comes to 36. 16 times 2 plus 4 is 36. And that's the limit. That would be the y value approached. Watch out, they might ask you something like this. Careful, now you can't stick 2 into here, because if you substitute in 2 minus 2 is 0, and you got division by 0. So what do we do? Now notice the notation, please, Matrix. Keep your limits. Keep the equal on the left. Keep your limit there and factorize. Difference of 2 squares. The x minus 2's, if you divide them, you get 1, which is great. That vanishes. And the limit as x approaches 2 of x plus 2 becomes 2 plus 2, which is 4. Now remember, as you stick in the 2, you then drop the limit. Please watch your notation on this. It's so important. Now they haven't really asked much of that, but they could quite easily put one of those in. But the main thing is leading to what we call in maths, gradient from first principles. Okay, but before, we've looked at the concept of a limit. Okay, Matrix, very nice, very easy. Watch your notation. Okay, now let's take this a little bit further. We're going to explore a concept called average gradient first, and then develop a formula. Watch this. I'm going to take a little parabola graph, find the average gradients, the word average gradients of the graph of fx equals x squared minus 4. That's a parabola between x's minus 1 and 3. Now I'm going to draw a little picture here for you. Let's draw a little picture. Okay, if you have a look here, what do we know? Now I'm not going to waste time sketching or doing all the details of sketching. This has x-intercepts at minus 2 and 2, but we're not worried. We're going to be looking at some points at 3 and at minus 1. Okay, so that would be about there. Okay, so we've got 3 and minus 1. So we've got 2 points. Now, the question is, what is this thing called average gradient? Okay, what is this thing called average gradient? Let's have a look. They definitely can ask you this as well. Now, average gradient is very simple. What it simply is if you join these 2 points on the graph, if you join those 2 points, let's call that A and that point's B. What that is saying, the average gradient of the red parabola is the gradient of the black line AB. So if you can get the gradient of line AB joining the 2 points on the parabola, that's called the average gradient of the parabola between 2 points. Okay, so that's in keyword, that word average. Okay, now how we do it is, remember, you all know how to work out gradients, so we need y values. So for x equals minus 1, let's see, what are we going to do? Let's work out the corresponding y value. So what's that? That's minus 1 squared minus 4, which is 1 minus 4 is negative 3. So A is the point minus 1 minus 3. And if x is equal to 3, how do we then go? We go the f of 3 is equal to, let's write that there, is equal to 3 squared minus 4, which is 9 minus 4, which is 5. So this is going to give you 3 and 5. Now, how do we get the average gradient? By simply working out the gradient between the points. How do we do that, matrix? 5 minus negative 3 divided by 3 minus negative 1. So that's 8 over 4, which of course is 2. Now that's the average gradient. That's the gradient of line AB, and it's the average gradient of the parabola between 2 points. Watch out, they might ask you a question like that. And we're going to take this further now into finding a very important formula for gradient. Stay with us. The plot is thickening, guys. It's getting exciting. Stay with us on Matrics Uploaded.